Hello and welcome to the continuation of the last video. In this video I'll hopefully finish the concept of tangent spaces and maybe make a remark on the vector fields of Euclidean or pseudo-Euclidean spaces. So there are also curves like xj1 equal to xj1 of t and xj2 equal to xj2 of t, passing from x for t equals 0 with tangent vectors at x, the vectors sigma 1 of x and sigma 2 of x respectively, and the curve xj 1 plus 2 of t is equal to 1/2 of xj 1 of 2t plus xj 2t. Please comment if that's linearity. But anyway, these passes from x for t equal to 0, and its tangent vector at x is dx 1 plus 2 of t by dt, evaluated for t equal to 0 is equal to sigma 1 of x plus sigma 2 of x, and hence sigma 1 of x plus sigma 2 of x is an element of the tangent space for Euclidean space. And in the tangent space Tx ρ3, we define an inner product induced by the Euclidean inner product of the underlying three-dimensional Euclidean space as sigma 1 of x times sigma 2 of x equals xj sigma j 1 of x times xk sigma k 2 of x is equal to xj times xk sigma 1 j of x times sigma 2 k of x is equal to let me see, the metric tensor with the indexes or with the indices jk of x times sigma 1 j of x times sigma 2 k of x. In Cartesian coordinates, the matrix g of x is just gjk of x of the metric tensor for any tangent space equal to the identity matrix I equals the chronicle delta with indices jk. And the length, or more generally the norm of a vector sigma of x, an element of Tx ρ3, is defined by the relationship that the length of sigma x, or the norm of sigma x, is by definition equal to the square root of sigma x times sigma x is equal to the square root of gjk of x times sigma j of x times sigma k of x. And for any x, an element of ρ3, the tangent space Tx ρ3 equipped with the above metric is a metric space. And by the same way, we are able to define the tangent space of a three-dimensional Minkowski space. I think I go over vector fields in the next video, because otherwise this is going to be too long. But thank you for watching, have a nice day.